Welcome to February's Global R&D Meeting. There's so much going on right now that we really had a hard time to pick what to present to you today. I mean, obviously, there has to be something about SNS and ckBTC, but well, let's have a look what else we have in store today. So we'll start with like a block on SNS, like all things SNS. So Georgi will tell us about the platform release together with Hamish on the timeline for OpenChat. Then Maria and her team will report on some of the load handling improvements that we have done over the last couple of weeks. The second blocks will then be updates. First of all, the update on the ledger standard. Then Tim will tell us everything about ICP.Lab and what happened in the DeFi week here. Then Samuel will tell us about some of the troubles with DNS and how we address those. Pete will give us an update on ckBTC. And finally, Sven will have some news on node provider rewards. Then our last block will be demos, where for once we start with the community demo, which today is a super impressive piece of work called Juno. So we'll learn what that is. The demos from the foundations today will be the Motoko garbage collection improvements and a WebSocket demo for how you can get WebSockets for smart contracts. So let's have a start and have a look at what happens with SNS and OpenChat. And of course, really excited about this one here because we will be talking about the timeline of the next few days and how we will see probably the first real DAO of the whole world coming into existence. So I'm handing over to Georgi and Hamish. Please take it away.
Thank you, Jan. Hi, everyone. My name is Georgi. I'm a senior engineering manager here at DFINITY. And today I'm going to talk about the service nervous system, or SNS for short. Next slide, please. So I'm pretty sure you remember the launch that happened in November 2022, which is 3 months ago, of the SNS platform. There was a lot of interest from the community. There was also a lot of learnings and feedback there. The first DAO back then was the SNS1, which was our dress rehearsal. We gave it a try and tried to make it a fun project. And thank you all for taking part in this and really helping us. Despite a few hiccups that we saw there, we actually are happy with the results and with the learnings that we got from that. And we managed to get it to a state where it's up and running. Next slide, please. So for the last 3 months, what we've been doing is looking at this feedback, but also from all the other ideas that we had in order to improve the experience and investing into that. And there are quite a few areas here that I have listed on the slide where we have spent some time. And on the next slide, please, I'll talk about a bit in more detail about what exactly we have added to this new release that's coming very soon. So one notable difference is the community fund. This is a way for the community to get some more investment into projects, cool projects, and also to use this staked maturity that is sitting there in the neurons. Another area where we have invested is improved payment flow. We are hoping that this time we have much, or rather next time when we launch a project on the SNS, we have much less refunds. Custom domain names, that's really cool, and it helps with decentralization. I'm pretty sure that at some moment in time, there will be a great demo there from the team. Asset canister security improvements, really important for the decentralization of projects. And then from a testing perspective and experience, test flight in mainnet, yes, it's possible. Not exactly the same like the real one, which runs on the SNS subnet, but still some very close. And last but not least, we have invested in tokenomics best practices, and we have published this online. Next slide, please. So what's coming is we are just now finishing the testing of the release candidate that we have selected and running the rigorous tests on this, end-to-end tests. The final no-go decision will be tomorrow. And if everything is great, then from there onwards, we will continue with creating proposals to publish the SNS code to NNS, and then the community can vote on that. And then the next steps really are the first project, which most probably will be OpenChat, can start the decentralization process. I'll give the word, next slide, please. And yes, as I mentioned a few times, read the documentation. There is, it has been updated. There is tons of valuable documentation about SNS, how it works, how it can be used, how it can be tested. And should there be any feedback, don't hesitate to reach out to us through the forum or any other means. And now I'll give it the word to Hamish, who will tell us about the OpenChat launch timeline. Thank you.
Thank you, Georgi. Hi, yes, I'm Hamish. I'm one of the OpenChat devs. And if you go to the next slide, I'll talk you through our process. So there is a proposal that is currently out for voting. And this proposal, if you see down at the bottom left of the chart, is a whitelist principle proposal. And what this proposal does is it authorizes a DFINITY controlled principle. It adds that DFINITY controlled principle to a whitelist in what's called the SNS WASM canister. And if this proposal passes, then DFINITY will be able to call into the SNS WASM canister to spin up a set of SNS canisters. This is a one-time thing. So once that call is made, the principle will then be removed from the canister. So they can only make that one set of SNS canisters. Once that's done, which will most likely be on Friday because the proposal runs for 4 days, DFINITY will then, the OpenChat team will then hand control of OpenChat over to those newly created SNS canisters. And then we will make a proposal to start the sale. And if all goes to plan, that proposal will be made on Friday evening UK time. Will run for 4 days, might run for less if it reaches a majority beforehand, but most likely it'll run for the full 4 days. And then there's a slight delay before the sale starts, and then the sale will start. So if all goes to plan, the sale will start on Wednesday. So get your ICP bags ready. And yeah, that's it.
Thank you, Hamish. I can't wait for the sale to start in like almost a week. So yeah, I'm definitely ready here. So yeah, let's move on. Because as many of you know, the SNS1 launch last year, which was meant to uncover bottlenecks and other load issues, actually did do its job and uncovered a few of those bottlenecks and other issues, how ICP handles load. And obviously to prepare for the OpenChat SNS launch and other future SNS launches, these needed to be addressed and have been done so. But in fact, most of them actually also helped to address load in general. And I think ICP is now a much better place. So Maria and team, please tell us more what was done.
Thanks, Jan. Next slide, please. Hi, everyone. Maria from engineering here. As Jan mentioned, SNS launch with a high load of update calls from sale participants surfaced a few issues and prompted us to do some optimizations both in the replica and also in the front-end app to improve efficiency and overall better user experience on the high loads. And I want to also repeat, while these optimizations were triggered by SNS1 high sale participation, there are also great improvements outside of SNS scope and made IC more efficient and in general for canisters improve, for front-end canisters improve the user experience. So the replica improvements will focus on processing update calls more efficiently and increasing the throughput. So these include, for example, caching signature verification for delegation and then certification time speed up. The canister and front-end optimizations were focused on reducing the number of update calls without compromising on security. So this included introducing SNS Aggregator canister that Lawrence is going to talk in more detail about, and other changes that are also useful engineering patterns for developing front ends on the IC that would like to share more details and can be also applied outside of SNS. But of course, very handy for next launches. Next slide, please. So I'd like to highlight briefly two optimizations in Replica because they're really worth mentioning. I mentioned them briefly last public Global R&D. So the first one is caching delegations in the crypto library that brought a really huge improvement, 11x for the throughput on large subnets and 800x speed up for canisters where the signature verification was cache versus uncached. And since this was presented in detail in non-public Global R&D, we decided to make a forum post explaining what we've done and provide more details about it. So stay tuned for the forum post. And the second one is certification optimization that also brought almost 4x improvement with the new tree hashing algorithm. Stay tuned for more details in one of the next public Global R&D. It's really worth highlighting and presenting the details here. So yeah, with that, I would pass on Lawrence with the aggregator updates. Thanks.
Hello, this is Lawrence. Please next slide. I'm India from DFINITY Engineering. So as you know, like the SNS allows the dApps to decentralize themselves. And what you might not know is that an SNS is actually the set of canisters, right? And when the users were accessing the SNS dApp frontend, we had to gather the information that we're showing to the user from different of these canisters, like maybe one part was from one specific canister, then the status from another one. And that made sense. But what this happened is that this triggered a lot of requests per user that access the page, right? And this is something that we already planned actually, like when we were like discussing this design and like how to implement it. But like the SNS after the SNS one, we decided to prioritize what I'm going to show you. So please next slide. So the solution that we had was to build this SNS aggregator canister, right? It's a canister that talks with each of these SNS canisters specifically, and then prepares like in this case like a file or like the response that aggregates the data from all the different canisters. This way, let's say when a user enters the SNS app, we get the data from the aggregator instead of making a request to each of the different canisters per project, right? So that improved a lot the performance, or we're expecting that it will improve a lot the performance of the next SNS project. And as more SNS projects come, they will become even more important for the performance. But this is the main improvement on the performance for the SNS related, but we have done other improvements. So please, next slide. I also forgot to mention that we will open also this aggregator canister to any developer that wants to interact with the SNSs, right? And to get the data directly from one source instead of like having to interact with all of them. So next slide. Other improvement that we have made that are more generic to the SNS app is that we have moved to using query calls. This is already in production for the users that are not logged in. We have also like loaded data only when it's needed. Sometimes we're loading data on initialization of the app to be more convenient, but to reduce the number of requests, we wait until the resource is needed to load it. And also we implemented a caching layer, right? Like in case that we might request the same information multiple times from the app, this layer will know whether to just reuse a previous response or to make a new call, right? And these are the improvements, especially from the aggregator canister. And now Arshavir will present us with the results of these improvements.
I'm Arshavir. I'm leading the load testing work for the SNS. And of course, as Lawrence mentioned, when we were designing the aggregator canister, we were expecting to get significant speedups. But we also wanted to be able to measure that on a testnet to get something concrete. And to that end, we conducted a series of 3 experiments, which are presented on this chart. In the first experiment, we were modeling the behavior of users who are not logged into the system. And therefore, as Lawrence mentioned, one of the optimizations is that the front end would only submit simple query calls, but to multiple SNS canisters. So here we're interested in the throughput of the system, which is defined in this case as the maximal number of requests per second or interactions per second. That's the x-axis, until which the system is able to serve at least 99% of the users successfully. So you see that for the first experiment, this number is around 480 RPS. In the second experiment, the scenario was very similar, except that we were modeling users that are actually logged into the system. This means that for every simple update call, it's duplicated with so for a simple query call, it's duplicated with an update call to ensure that the data that we receive is actually certified. And here you see that the throughput of the system drops down to around 120 RPS. And finally, in the third experiment, we installed the aggregator canister on the same subnet, and we repeated the experiment. And here it doesn't matter whether this is the logged in user case or the not logged in user case, because with the aggregator canister, there is only one certified query call that needs to be performed. And so you can see that on the next slide, please. We have a 2.5x speed up compared to the logged out user situation, and 10x speed up for users that are logged in. Next slide, please. So a few observations here is that eventually, of course, we see a degradation, which is because we're hitting some hard constraints on the subnet, such as the maximal number of ingress messages or queries that we can process per thread. However, even at the point of maximal capacity, the system is still demonstrating stable query durations, which is a good sign. Next slide. And the last point I wanted to make is that here on this testnet, we only had a single SNS, and we already see a significant speed up. In production, we will have multiple SNSs, and the aggregator canister with its improved architecture for the SNS will demonstrate even better improvements the more SNSs we have. With that, thank you, and back to you, Jan.
Thanks, Arshavir, and also thanks to everybody involved in this great work speeding things up. So one of the key elements of an SNS is obviously a governance token ledger. And also here, we have some improvements to make sure that these ledgers, these tokens can be integrated in all kinds of DEXs, and the SNSs can really lift off. Roman has all the news here. Roman.
Hello, I'm Roman. I'm staff engineer at DFINITY, and I'm going to give you an update on the ICRC2 standard. So what it is. So first of all, about half a year ago, there was a vote on the standard for ledgers on the internet computer. It was ICRC1 fungible token standard, which enabled basic ledger functionality, and it was generic enough so that we can integrate it in all existing ledgers. So ICRC2 is an extension of this standard, which adds new features using the ICRC1 extension mechanism. And the feature I'm going to show you today is it allows to delegate your transfer permissions. So often you want to enable some other party, like, for example, a canister, to make transfers from your account on your behalf. And ICRC2 is exactly about this one. So why do you want to do this in the first place? So first of all, I think the reason number one, it enables safer payment flows. So currently, if you make a payment flow, if you make a payment on the internet computer, what you often have to do is you make a transfer first, and then you need to notify the receiver of the funds about the transfer. If you do it from your browser, there is a possibility that your network connection would be lost, your app will crash or something like that, and the app might forget the context in which it made the payment, and you will have to go through a refund mechanism. So the ICRC2 flow allows apps to make the flow safer. In this case, you just approve transfers as the first call, and then you initiate the transfer on chain directly as the second call. So if something happens between the calls, the first thing that can happen is that there will be some approval for some time, but eventually it will expire and you won't lose anything. So another use case for a delegation is a recurrent payments mechanism. It's similar to subscriptions, for example. So you could implement something like YouTube subscription or similar thing when you allow some apps to withdraw funds from your account and you won't need to remember to go and pay every month, for example. And another use case that we have in mind is certain transfer amounts. For example, this is useful for trading algorithms when you say, I want to buy up to N tokens and the highest price is X and so on. So you don't know in advance how much the algorithm will spend. So just pre-approve some amount and the algorithm will do the best it can. So how are we going to do this? So we the tokenization, ledger and tokenization working group designed the set of endpoints based on the RC20 standard. And let's go to the next slide. I'm going to tell you a bit more about how it works. So first of all, let's discuss the entities involved in the transaction. So we have three entities. We have the owner, which is usually you. You have some funds on the ledger, and you can have multiple accounts. Right? ICRC1 standard allows you to have multiple accounts. So you own some account, and you can delegate your ability to transfer from this account to some other principal who is a spender. And then the spender, once it gets approval, can transfer from your account as if the spender were you. And you can also limit how long the approval will live and the maximum allowance that the spender can use. So next slide, please. So here is the basic flow, how the feature works once it's implemented. So the owner of the account, usually you in your browser, you initiate the transaction called ICRC2 approve. You specify which account of yours should be used, who is the spender, and how much you want to approve. You send this request to the ledger. If everything goes fine, when the spender can call allowance endpoint, and it must specify the account and like who is the spender. Usually it's the same who is the caller, and the ledger will tell the exact same allowance that the owner approved. Then the spender can initiate transfer from this account to any other entity in the system, to any other account, as if the transfer came from you, and it can use specify the amount up to the approval. So if all the conditions are met, if you have enough funds on your account, and if the amount doesn't exceed the approval, everything should go fine, and the funds will be transferred, and then the allowance will be decreased by the amount spent by the spender, and of course your balance will be decreased by the amount as well. And the next slide, please. So there is already a standard called RC20 for Ethereum networks, Ethereum network, which provides similar capability. So we took our inspiration from this standard, but we added some features to make it work nicer on the internet computer. So first of all, RC20 does not allow expirations. So we added optional expiration times to all approvals. So you can approve, for example, for 5 minutes, and then after 5 minutes, the spender won't be able to transfer funds anymore, and this greatly improves security of payment flows. And another issue with RC20 is that if you approve something, the last approval wins, which doesn't work well with concurrent modifications that we have on the internet computer. So if you have multiple concurrent approvals and spends, this just don't work, and it doesn't work with asynchronous at all. So we decided to make approvals additive. So if you approve 100 and then 200, the total allowance will go 300. And if you want to remove all approval, you just approve negative amount, like minus 1 million, and then it becomes 0 again. And of course, the ICRC2 plays nicely with all the features of ICRC1. It has works nice with sub accounts. It supports schemas and supports deduplication features as well. So the next slide, please. And the next step for the evolution of ICRC2, we're going to have a working group vote on the standard soon. If everything goes fine and there are no blockers, we will submit a governance proposal to learn the opinion of the IC community about the standard. If everything goes fine, we will implement the standard in the ICP ledger first. And then once it's done and we tested it properly, we will implement it for ckBTC and all the SNS ledgers as well. And if you find this sort of stuff exciting, you can join the working group for ledger and tokenization. We are always looking for new members. That's all on my side. Thanks a lot for your attention.
Thank you, Roman. And we sort of stay on the topic of ledgers, namely the latest ICP.Lab was on DeFi, all things ledgers, how to make money on chain and all of that. Tim, tell us more about what is ICP.Labs and how did the DeFi week go?
Yeah, it's my pleasure. Thanks, everyone. Hi, everyone. My name is Tim. I'm a developer partner engineer at DFINITY, working in a growth team. And one of the initiatives that we run is the ICP.Lab. So please to the next slide. So for the ones who don't know what ICP.Lab is, it is an advanced, tailored, and intensive program run by us. And we invite the most promising teams that build on our blockchains to come to Zurich. And here they come over for a week to meet our engineering teams, to find out what the bottlenecks are, to learn from each other, to help each other, and to really accelerate the growth for us and for the teams. I put a QR code where you can go to the website of ICP.Lab. Please go to the next slide. So we had 2 ICP.Lab workshops in 2022. In April, we had the team from Infinity swap over, and in November last year, we had the Discover and the Merchant Labs over. And one of the learnings from having 2 teams over was they had very different focuses, one being a social app, the other one being a tooling infrastructure app or provider. And we realized that there was always like not so many synergies. So we wanted to do, first of all, we wanted to scale ICP.Lab this year. And at the same time, we really wanted to focus it on an industry. And the first one we've done was 2 weeks ago, from the 6th to the 9th of February, where we invited all the promising teams in the DeFi space. So we had, again, Infinity Swap over. We had ICP Leak from China over, Astro-X with their wallet app ME, IC Lighthouse, Finterest, the lending platform Helix, Order Book Dex, EX3, the AirGap wallet. And then also we had Yumi and Chico as local players from Zurich over. And if you go to the next slide, I share what happened during the week. So the teams arrived on Monday and had an introduction session where they introduced themselves and we introduced ourselves to them. And afterwards, they got a session from our research team on the research initiatives that has happened and also that will come in the future. And on Monday afternoon, we invited around 35 VCs to our office for a VC matchmaking event where the teams could meet potential VCs and show their products and find new contacts for the future. And after the VC matchmaking event, we opened it to the public, where we had a DeFi meetup. You can see that in the top left, we had a full house in our office with lots of DeFi enthusiasts in the crypto scene in Switzerland, a really fun night. And for the rest of the week, we had many different sessions and workshops with our research and engineering teams, where they really got closer together and found potential bottlenecks and ways to improve. So if you go to the next slide, some of the outcomes, what the teams mentioned that I found was quite profound, was they said they could really understand our R&D teams better. Often when you're far away, you think like, can't this be fixed in a week or two? And they said after like being with them for a week and listening what our challenges are as well, they could really understand better why things take time. And also the interaction between our teams and the visiting teams, but also between the visiting teams where they found synergies and realized, oh, we actually have the same problem, or we actually want to do the same, and the networking for that. And on Wednesday, we had a day fully on financial integration, where we had a ckBTC and BTC discussion, and that was followed by a discussion on how can we integrate Ethereum to our chain. And this has led to a joint initiative from different teams that has been visiting, and our teams to work on that. And I've linked the thread to the forum where there's more information about that. And you also find more stuff going on in our developer Discord. If you can please go to my last slide. So what's coming next with ICP.Lab? We're planning to host one per quarter in 2023. And in Q2, the plan is to have one on the topic of metaverse and gaming. And if you're a developer and you have a project, please feel free to apply for ICP.Lab. So I put a QR code there, which leads you directly to the application form. And the ICP.Lab physical cohorts are really based on technical matters and going deep there. And we also realized that many of the teams that building on the IC have potential rooms for improvement in business topics. So we will launch ICP.Lab Business Booster series, which will be a virtual webinar series where we discuss more tokenomics, how to do designs in Web3, how is PR and marketing done, and topics like that will be launched very soon. That was it from me. Thank you very much, and enjoy the rest of the meeting.
Thanks, Tim. You might have heard that Spamhaus has put ICP.Lab on their blog list last week, and demonstrated like once more that DNS can really be an Achilles heel of the internet computer. So Samuel, tell us what happened, what the DNS dangers are, and how ICP can deal with all of that.
Thank you, Jan. Hi, IC people. My name is Samuel, or just Sam. I'm leading the DFINITY engineering team. Let's please go to the next slide. So as Jan mentioned, last week, the IC faced the challenging situation when the IC's default domain, which is ic0.app, was temporarily added to a block list. And this raises general questions about the use of domain names. The foundation knew about those risks for a while and worked on mitigations for the past months already. However, then last week's events accelerated our efforts, and we put some precautionary measures in place earlier than we had originally planned. So let's look at the overall situation. We are faced with a conundrum. On one hand, the domain name system is based on some centralized components, which is in contradiction to the decentralized nature of the IC. On the other hand, domains are a very convenient way for humans to access internet services, and that's why the IC is using domains. So currently, the default domain is ic0.app, which is registered by the DFINITY Foundation, and the app top-level domain is controlled by Google. As most of you know, and I think that's more of a repetition, every canister gets automatically accessible through its canister ID and the ic0.app domain. And then system services such as Internet Identity and the SNS Frontend app are also accessible through ic0.app. So far, developers could expose their dApps through custom domains only if they used a custom-made or self-made service worker. And finally, ic0.app is also used for API calls. If, for example, your agent.js in your browser wants to call a canister, it uses this default domain as a standard. So what are the problems with this situation? And let's please go to the next slide. First, we have centralized control. With a single domain and no decentralized DNS, a single entity controls access to the IC. A few months back, we presented a target architecture for boundary nodes that foresees multiple parties to run HTTP gateways. They will provide access to the IC through multiple domains, and this will address this centralized control problem. However, this work is in progress and will not be fully rolled out for a few more weeks or months, but that's what we work on. Then the next problem is takedown requests. Last year, the foundation established a code of conduct in collaboration with the community that is used as a guiding principle to block access to canisters with content that is violating this code. This could be, for example, phishing websites which are served off a canister running on the IC. It's important to emphasize that such smart contracts are not changed if they're blocked. They're simply not accessible through IC0.app. And in the future, once we have these HTTP gateways, these operators can decide for themselves whether to route traffic to such canisters or to block them. Finally, and that's what happened last week, a domain can be blocked or added to a block list. So if a domain is notoriously used to serve problematic content, eventually the reputation of the domain is affected and it might get added to a block list. As a result, social media messages or emails containing a URL with this domain are flagged as spam, or even worse, an ICP may decide to block access to the domain. There's multiple pieces to a solution. First of all, the filtering, as mentioned before, helps to retain the domain's reputation. Another solution is to isolate services from the default domain. And here we have very good news. Just a few days ago, the boundary node team released a custom domain feature. If I'm not mistaken, was demoed in previous Global R&D meetings. And this allows developers to use custom domains without the need to handcraft a service worker. So I recommend go and check this out. This is a very helpful feature. Another solution or step is to isolate the API calls on a separate domain. And finally, we work on making Internet Identity and the SNS frontend app browsable through a separate domain. That's work in progress. Should your ISP block access to a domain, you should always be able to bypass these restrictions using VPN or by making some local DNS configuration changes. That's this overview. And now let's go please to the next slide, where I'd like to talk about Internet Identity and more specifically WebAuthn. So you may wonder, why don't you just host Internet Identity on a new domain and we're done? Making this move is a bit more involved, and that's because we use WebAuthn for authentication. And as per this WebAuthn standard, a secure chip generates a different public key for each domain. So for example, when you use your secure enclave on your laptop and access II under IC0.app, you will get one key. If you use the same laptop now, but authenticate to II under internetcomputer.org, you will get a different key. And as a result, users need to actively configure II that these keys belong to the same II anchor. This configuration requires both the old and the new domain to be accessible, and therefore IC0.app needs to be accessible until users have migrated. The Geeks team who builds II is implementing a migration wizard that will guide users through this process, and we expect this wizard to be available in a few weeks. So stay tuned for that. If you don't want to wait, and actually we recommend what I explain now, you can also use an alternative flow. You can store the recovery phrase of your II anchor, and then should II be launched on a new domain, you can recover your anchor there. And with this, let's go to the last slide, which is a more detailed overview of what happened last week. On Tuesday, Spamhaus, which is a non-for-profit organization who curates block lists, added IC0.app to their block list. The foundation then reached out to Spamhaus, explained the IC architecture and the foundation's code of conduct efforts, but there was no positive feedback, at least not initially. Therefore, we then released some emergency changes on Friday. We launched a second default domain for canisters, that's ICP0.io. We launched an isolated domain for API calls, ICP-API.io. And we made II and the NNS frontend app accessible under internetcomputer.org. We also informed the community about these updates and encouraged everybody to store their II recovery phrase. Luckily, it was a big relief. On Sunday, Spamhaus informed us that IC0.app is no longer on the block list. So therefore, we no longer encourage the community to activate their II anchor under the new domain right away. Let's rather wait until the migration wizard that I explained before will be available. So in summary, we still recommend to store II's recovery phrase. It's good that IC0.app is no longer on the block list, but clearly some risks remain, and that means we have quite some work ahead of us. I hope that explains what happened. And with this, I hand back to you, Jan.
Thanks, Samuel. Since we last spoke, ckBTC has seen the light of day, and actually since just the couple of days it's alive, more than 10K transactions have already been made of ckBTC, and hopefully you have done some of those things yourself. It's like over to Pete for an update on ckBTC.
Thanks, Jan. Next slide. So yeah, as Jan mentioned, I'm Pete. I'm head of product here at DFINITY. And as Jan mentioned, like only a month ago, Manny was here, and we had CK test BTC, but the real thing was still something in the future. So super exciting to say that, like, since then, the NNS proposals to create the ckBTC canisters both passed, and we have both ckBTC canisters live on the Internet Computer today. The ckBTC ledger canister is fully launched and available for integration to anybody. And you can see the activity already on the ckBTC Ledger Explorer on the Internet Computer dashboard. The ckBTC minter, however, as handling Bitcoin, real Bitcoin on the IC is a big responsibility, we're taking somewhat of a safety first approach to rolling out these BTC to ckBTC and BTC to ckBTC flows. And the access to these two functions is proposed to be rolled out in a more gradual manner. All the activity on the ckBTC minter is transparent, and you can go and see the metrics on the metrics dashboard that Manu demoed last time. The ledger canister is using the ICRC1 standard, so it should be super easy for projects to integrate with. And DFINITY has been working with some of the IC's leading social and GameFi applications to seed our community's end user wallets with ckBTC and bootstrap some activity and use cases in the ecosystem. Next slide. So what gets lost as BTC is digital gold in the wider conversation today is the original vision in the BTC white paper of Satoshi was this idea of a native internet money, which was capable of supporting small casual transactions, which is why we share the excitement of this tweet here, which is, what can be more casual than a ckBTC tip being used in a social media app. So a big thanks to the Discover team for helping make this historic moment happen. Next slide. OpenChat also added support for ckBTC in that wallet. So users can now easily send small amounts of Bitcoin instantly and at low cost via a decentralized chat app. Interestingly, I think the Chinese super apps have shown what's possible when chat and payments are combined. So now I think it's time to bring super chat to the rest of the world via the blockchain. Next slide. Of course, ckBTC should be convertible to and from ICP or any other token. So a big call out to ICP Swap and ICDEX for being on the bleeding edge here and introducing trading pairs for ckBTC and ICP. Liquidity is a bit thin at the moment, but we're working on looking to help improve that soon. And trading pairs should be coming to other ICDEXs soon. Next slide. DGastonia, I hope I'm pronouncing that right, the NFT analytics tool, took a step further. ckBTC is only worth 1 BTC if the value can be easily transferred between the networks by anyone without a bridge or a centralized custodian. So the NNS proposal to allow end user redeeming of ckBTC for BTC passed last week. And then very shortly afterwards, the DGastonia dApp was the first wallet UI to execute a redemption to a Bitcoin address on the Bitcoin network. So a big shout out to the team for jumping on the opportunity so quickly. Though note that as you're sending Bitcoin to the Bitcoin network, the higher Bitcoin network fees will get deducted from this kind of transfer. Next slide. And not forgetting the NNS's own UI. You may have seen that the team added the first support for ckBTC tokens a few weeks ago. Coming soon will be a slight refresh of the token UI with the NNS front end, which will hopefully make sending and receiving both Bitcoin and ckBTC value as seamless and easy as possible, just as a digital twin should really be. Next slide. So with a big thanks to the community contributions, we're super excited to see that we've seen more than 11,000 transactions so far on the ledger. And if we do a quick cost comparison between what it would cost on Bitcoin versus the ckBTC network, each ckBTC transaction costs 10 Satoshis, or about 2 cents today. So those 11,000 transactions have cost about $28 in total. The same level of activity on the Bitcoin network, assuming about $1 per transaction, which is about what it is today, would have cost more than $11,500. And of course, our transactions are almost instantaneous, whilst on the Bitcoin network, you'll be typically waiting for about 30 minutes for enough confirmations. So in conclusion, this is really sort of the beginning, and we really look forward to seeing how ckBTC can be incorporated into many more dApps on the IC. And back to you, Jan. Thanks very much.
Thank you, Pete. I'm sure with all this work, the Internet Computer will be a very busy place, and for sure we'll need more node providers into the network to add all the capacity for all this exciting stuff to be hosted. And because we have already seen a few proposals by future node providers and being accepted by the NNS, and more of those I'm sure will come. One piece is missing here, and we're staying on the topic of tokens, namely how many ICPs will node provider get remunerated in the future. Sven, over to you.
Yeah. Okay, thank you, Jan. If you go to the next slide, I think Jan already gave an excellent introduction. In this brief update, I want to give an outline of a proposal that we're preparing for rewarding of new node providers, which is slightly different from the existing situation. It's already published on the Internet Computer Wiki, and I will share a link later on in this slide deck. And there's also an active discussion on the forum. But please be on the lookout as well for a motion proposal, which will be submitted pretty shortly. So why a new proposal for node provider remuneration? Basically for two simple reasons. New node providers will have different hardware that will be the basis for their nodes compared to the Genesis launch 2 years ago. And that hardware is just simply more expensive. So the rewards need to be adjusted based on that. But secondly, as well, the existing remuneration that is implemented in the NNS does not give any stimulus to set up new nodes, for example, in new regions, or stimulate new node providers to set up new nodes in new data centers. So it's very difficult to stimulate further decentralization. And those are two main reasons for defining a new remuneration model that we currently have under discussion on the forum. If you go to the next slide, Just as a quick recap, we got two different types of hardware, Gen 1 hardware and Gen 2 hardware. Gen 1 hardware is basically the hardware specification that has been used during the Genesis launch by node providers. That hardware has been upgraded in the past, also with storage upgrade, and that actually those storage upgrades are currently also continuing. And there's a separate remuneration for those node providers. Probably that remuneration is also going to be updated to take into account the new storage, but we're not going to talk about it in this presentation. Probably that's going to be shared in one of the future global R&Ds, as a proposal for that remuneration is also being prepared. But in this quick update, I want to give a brief outline of the remuneration for new node providers that use Gen 2 hardware, which is basically a higher specification, and also includes new features like support of SAP, SMP, so that we can have more secure subnets. It's definitely not an end-state remuneration. It is a remuneration model that takes into account a few factors for decentralization, and we expect that there will be additional updates based on the community feedback, and we need to submit additional proposals for the community to vote upon. But it is the first step towards a more, let's say, professional and future-proof remuneration model. If you go to the next slide. This remuneration goes hand in hand with the decentralization activities. We gave an update of decentralization activities, I think 1 or 2 months ago in the Global R&D. Just as a quick recap and update, you can see here in the slides what we are currently working on together with the community. There's a Gen 2 hardware specification already published, and there are several sample configurations currently being tested to make sure that they're fully compliant with the IC network. As you can see, some of them have already been completed, some of them are still in progress. Like Jan said, we have several node providers that are very interested to join as a Gen 2 node provider in the IC network. And already some of those have submitted proposals that have been approved by the community. So a few of those node providers are already actively preparing to set up the nodes and add them to the network. And where does that lead us in terms of the IC network? Currently, there are about 627 nodes, and they're divided into about 30 subnets, of which the SNS subnet is the biggest one with 40 nodes. And the expectation, but that of course depends on the growth of the IC and the growth of the community, is that we need to grow the decentralized network in capacity about, let's say 40 to 50%, and probably also increase the size of the subnets to make them more secure. And if you go to the next slide, where does that lead us in terms of decentralization? Well, in a perfect decentralized world, you would have only one node per node provider in a subnet, and you would have only one node per data center in a subnet. So if you got the SNS subnet, which has 40 nodes, then you would at least need to have 40 node providers and at least to have 40 different data centers. That would be the perfect, let's say, decentralization score. Then again, also preferably we should have 40 countries, but that is a lot of countries to have nodes in. So probably the best starting point for decentralization would be the situation where no single country is able to stall the IC by taking over all the nodes in a country. So those are decentralization goals that we suggest we should aim for in, let's say, all the remuneration and decentralization activities. And that is also where the remuneration proposal that is currently being discussed in the forum is based upon. And if you translate it into, let's say, simple algorithms, it means that a node provider should not have more nodes than there are subnets in the IC. Node provider should be incentivized to join, of course, the IC, but the more nodes are added, the less incentivized they should be. And there should also be an incentive for node providers to join in new regions, and preferably also to set up nodes in new data centers. So those are the rough outlines of the remuneration. And if you go to the next slide, all those outlines, those remuneration principles, they are included in a formula and algorithm that is on the Internet Computer Wiki. You can see the link to the Internet Computer Wiki below. But to simply summarize it, if you take that formula and you put it into a graph and you picture the additional, let's say, profit margin or cash flow you get from each additional node as a node provider, you get this graph that you see on this slide. And here you see, for example, with the green line, that the remuneration for a node provider to add new nodes in a new region like Asia is actually quite high, and it still remains quite high if you add 20, 30 or 40 nodes. But for example, in the EU, in which we have already a lot of nodes, but not in every country, it's less interesting to add more nodes, but it's still interesting to add, for example, 10 to 15 nodes. And in the US, where we got a lot of nodes, it is less interesting at all to add new nodes, maybe 1 or 2 nodes to add a few more node providers, but that's basically it. So that is roughly the outline of the remuneration proposal. Yeah, please be on the lookout for further discussions on the forum and also for the submission of the motion proposal. And I'm happy to see all your feedback on it. And please reach out to me on the forum or directly if you have any questions on that. Back to you, Jan.
Thank you, Sven. So we are going towards demo time. Unfortunately, we are a little over time, but I think we're still going to have all the demos. They are so exciting. We should not miss out of them. Hopefully you can still make your agenda, everybody. So without saying too much, the first one is the community demo, which is a super cool project that David Tudusco has done in his for his fellow front-end developers, and he has done that in his time that he's not working on for the foundation and improving the SNS front-end app. So David, tell us about what you call blockchain as a service solution.
Yeah, thanks, Jan. I'm David, contractor, and fun fact, I'm close to 600 days having visited the forum. And given my experience, developer, I still think that despite the fact that the IC has really improved, it's still really difficult for the millions of front-end developers forward to access the IC because it's a new concept, it's often a new language, you have to learn Motoko or Rust, and it's also a new toolchain that is not JavaScripty, so it doesn't begin with NPM. So that's why I built Juno, platform or ecosystem that aims to bring the Web2 developer experience, like in the good old days, let's say, to every front-end developer of the world so that they can also discover Web3 and per extension, the IC. So as you said, Jan, basically, you can imagine that there is that notion of serverless on Web2, like Google Firebase and so on. And I want to do that with Juno, or I do the same with Juno, which I call blockchainless. So it works like that. The developer comes to Juno, and through Juno, the developer can create apps, which I call satellites. But what's important is to know that the developer controls the app. Juno controls nothing. And if you can think of a satellite is like a canister, except that it's not empty. When a developer starts the satellites come with an authentication, a database, a storage, and hosting. It's like the developer doesn't start from scratch, he starts with something, right? So I try to be quick to stick to the plan here. So when you go to Juno's console, you sign in with 2. That's a demo encore. And when you're gonna land in your console, you have your apps, your project. You can create new satellites if you want. There is like an easy wizard, but to spare time, we're just gonna use the one I've created yesterday evening. And when you are a developer, when you have your satellites, then you go to your app. Here it's a simple React app I've built the other day. You connect your app with your satellite and you are already good to go. Then when you sign in, so it's not the developer anymore. Let's think that's like a user of your app that's signing in your app. The cool thing about Juno is that when you go to your console, then you're gonna see everybody that's signing in your app. For example, if I sign it in that other browser with an other encore, let's see that's a second user. Here, if I refresh, maybe Yeah, let's go. Yeah. You see, now I've got 2 entries. So anonymously, I know the user that I've signed in my app. And the cool stuff about that is that I can grant access as a developer to a couple of services. Like here, for example, if I want people to allow to write things, I have to tell where will that be saved in my satellites. So I can go here and I say, okay, I want this data to be saved in something called data. That's like a generic name I can choose, right? And when I do that, here I got, hello, the IC is super, right? So that's a user that has entered something. You see, it works, it's persisted on the IC, and me as a developer can go in my console, and here I see what the user does. And where it's cool, it's I can also say, me as a developer want to give privacy, so I can also say that I don't want to know about the user's data. You see, if I go back here, it's empty. And if I got 1 more minute, the other thing which I did the same concept, but for images, because I noticed that often for beginners, it's really difficult to start building things like uploading video or uploading images. So I already integrated that in Juno so that the developer has not much to do as creating a collection, like it's called. And if everything goes according to plan, we are still in beta here, right? You see here, I also got an image that is saved. I can open it. We are on chain. And custom domain are also supported. So it's like super easy to just plug a domain that's going to be .com. You got your entry, blah, blah, blah. And it's like zero complication. And one thing important is here, as a developer, I just write front-end code. So it's like 1 function, 2 parameter, 1 function, 2 parameter, and the whole demo I did was just that. So yeah, that's it. Juno is currently in beta. If everybody want to join the movement and build something, just reach out, drop me a message. I'm happy to provide an invitation code. And on juno.build, you can find lots of documentation. There is also like a 1-hour video when I go in depth in the product with Cedric from ConnectSpeed. And yeah, if you have any question, let me know.
Thanks, David, so much. This is wonderful. So the next demo is for all the Motoko coders out there, and I'm sure you all will be very excited about this one. And yeah, Luke, tell us more about Young garbage collection.
Thanks, Jan. So I'm Luke, a software engineer in the Motoko language team, and I'm excited to present a new garbage collector. It's the generational garbage collector with the aim to improve performance in Motoko. So the idea is really that the program has more time for its own execution and the garbage collection over its shrinks. If we go to the next slide, we see the garbage collection benchmark. There are several benchmark cases, and here showing the average results, the WebAssembly instructions, and comparing the generational GC against the classical, the existing copying GC in Motoko. And we see 2 things. One is that program runtime drops by 14%, so programs run faster, consume less cycles eventually, and also more substantially, the garbage collection pauses. So the work that the garbage collection does on average shrinks by 3x, which is noticeable. If we go to the next slide, I would like to explain a little bit how it works. Just in a nutshell, the idea of the garbage collector is based on a hypothesis, which says that many objects in practical programs just tend to live for a short time. And the garbage collector tries to exploit that phenomenon by partitioning the heap in 2 spaces. One is the young generation, and the other is the old generation. The young generation hosts all objects that have been recently created since the last garbage collection run, while in the old generation, all objects live that have been around for a while, that have survived already garbage collection. The idea is now to focus on this young generation by performing a frequent collection, which is cheap because that generation is small. And then eventually the aim is to offer fast reclamation of short-lived objects. On the next slide, I would like to zoom in the young generation collection. So the optimized path of the garbage collector. In a first step, the garbage collector needs to identify the alive objects by marking those. This is here illustrated by the dark orange objects. The surviving objects are eventually moved down to the bottom of the young generation, which is compacting the heap and also eliminating fragmentation. And eventually the surviving young objects are added to the old generation called promotion, which is super simple by just moving a pointer. And then the whole thing can start over. If we go to the next slide, the main program can continue to again allocate objects which are again young and accommodated in the young generation. The only critical thing that the generational garbage collector needs to consider is when a pointer is installed in an old object that points to a young object. These, like special pointers, rights are caught by a barrier and eventually serve again for marking as anchor points for marking. So now, if I may take over the screen, I would like to demonstrate how the garbage collector works. So this here is actually showing two canisters, the same program code, an example from the benchmark taken. In the first, upper part, it's a canister with the source code running with the generational GC, while in the lower part of the screen here, it's the same source code just being compiled with using the copying GC. And this is like a front-end canister attaching to those. On the left side, on the charts, one sees in the blue shaded area, that's the heap space that is continuously growing, because in this scenario, there are continuously new large objects being allocated. And from time to time, the whole structure, they are added to a structure, the structure is dropped. So whenever the curve drops, that means that the garbage collector has performed some work in reclaiming memory. The middle graph shows the total reclaimed memory so far. And most interestingly is on the right side, showing the runtime costs of the program. The main program is the mutated. That's not interesting here, so I fade that out. And we concentrate on the red curve, which shows the garbage collector. And one sees here quite nicely that the generational GC has very regular spikes, so a regular amount of work being performed in a decent amount, while the copying GC has an irregular pattern of sometimes very high spikes, which shows that the generational GC performs much smoother, less disruptive, and also faster work. If I go back to the slides, I would like to invite you to try out the new garbage collector. The new garbage collector can currently be enabled by an explicit compiler option, --generational-GC or DFX-JSON option. And we also plan to offer the garbage collector as the default garbage collector in future. I highly invite you to for feedback. So feedback is very appreciated. I will also take that opportunity to thank Claudia and Ulan for the contribution and review of the garbage collector and giving a brief outlook what's coming up next. That's an incremental garbage collector which has a different aim, namely in scalability, to be able to use arbitrarily large heap sizes. So thank you for attention, and back to you, Jan.
Thanks, Luc. So our last demo, Kobi will show us how we can set up WebSockets for canisters. Please, Kobi.
Thank you. Hi, I'm Kobi from Boundary Nodes at DFINITY, and I have the pleasure of talking about WebSockets, which I've been working on. All right, so let me explain by first explaining how it is without WebSockets. Okay, so the way to interact with the IC is through update and query calls. And then let's think about the example of some notification. So there's something on the IC which we want to get to know, like some message. And then what do we do? Okay, as it is right now, it's usually the case that the developer would implement polling himself. So the client would go, is there a message for me? Is there a message for me? Which is a bit less easy to think about, less convenient. The usual way to do this in the Web 2 world is you can open a WebSocket, then you can, like the server can send you a message at will. And it would be convenient to have something like this for the IC. All right, next slide, please. So here I want to make the point that I'm far from the only person that thinks WebSockets are a good thing, and it's been a very highly requested feature. And this can testify to the fact that this would reduce the friction for developers, and yeah, WebSockets are convenient. So then let me explain how this is going to work on the next slide. So the basic premise, it's okay, the WebSocket, it needs, like the other point, needs to be a single machine. So we will call this machine gateway. And then if you go to the next slide, the gateway is going to, like, it can talk to the IC with update and query calls, and we can talk to the gateway with WebSocket. So the gateway, in a sense, it like hides this inconvenience or complexity from us. We can have a WebSocket and be happy about the ways we used to. If we go to the next slide, yeah, so clearly, if we go naively about this, things can go wrong. And of course, we don't want this gateway to be some sort of trusted party where the gateway tells us something, this comes from the canister, we just believe. So let me then explain, like sketch the security of how this is going to work. All right, first I'm going to talk about the direction from the client to the IC. So what we're going to do, okay, so here, example, I open some front end, I'm served from the IC, then the front end is going to make, first, we're going to make an update call where I put my public key on the IC, then I'm going to be identified with this, like the canister can identify me with this public key. And then if I sign with this public key later, the canister knows it's the same party that first made the update call. Okay, so this will be sort of easy. Then I can open the WebSocket to the gateway. The gateway can talk with the IC. Then if I have a message, I can sign it, give it to the gateway. Now gateway can only pass on my message. It cannot like make new messages and pretend it's me because it cannot sign for me. If we go to the next slide, then I'm going to talk about certification. Okay, so canisters can make some certified data, then the subnet is going to sign, okay, this really comes from the IC. Then when the gateway sees something for me, it gets the data, the notification, what have you, and it's signed. Then it passes on to me with the certificate, so that, again, it cannot pretend that there's something, it comes from the canister, it has to have the certificate. So indeed, any communication between me and the canister has to be, if it goes to the canister, it's from me. If it goes to me, it's from the canister, indeed. So the point here, the gateway, I mean, of course, the gateway can like break down and stop passing on messages, but otherwise, there's no way to trick either side. So it cannot trick the canister, it cannot trick me. So it's sort of, I mean, like a internet cable. Okay, if we go to the next slide, then I'm going to just do a quick demo. Okay, here I have just my canister address. I go to my canister, and we see our example front end. Okay, so yeah, here I just want to make the point. So this is in this front end, indeed, right? It opens a WebSocket connection. I don't need to think about like I'm used to in the Web 2 to do it this way. I don't need to now translate this to polling, query calls, update calls. Now I look at some more messages arriving. Okay, the point here, the messages arriving are really like the front end. It knows they are from the IC because they are certified. And yeah, we have a convenient WebSocket. So that concludes my very simple demo. Yeah, soon we will, like, okay, mid-March, we should release this on GitHub. So ultimately, the point would be that this is offered on the IC. Like right now, the gateway will not be set up so soon. So you can look at our code. You can play with the gateway yourself. You can run it yourself. This should be available in mid-March after security review. And I guess that's everything I had to say.
Thanks, Kobe. Looking forward to everybody running his WebSocket code themselves, maybe at some point on the boundary nodes. So before we conclude, there's like one more thing to announce. Yeah, so ICP will go to ETHDenver. So we will have a booth there. We'll sponsor a co-working space, and the number of us will be there on the ground and help developers from the ETH community to onboard onto ICP. In particular, Kyle will do like a workshop for developers on the 27th, and I'll also be there for a keynote presentation. So hope to see all of you there, and yeah, let's attract a ton of Ethereum developers to build on the IC as well. So thanks for attending today. Sorry we ran over time, and hopefully see you next time on March 29. Bye-bye. Thank you.